After that, we are going to use convolution theorem. So, f of t into g of t equal to convolution of f of t and g of t, which is has some formula, that is integral 0 to t f of u g of t minus u into du. Okay. So, here we have chosen like f of u as e power minus au from that last step, and g of t minus u is e power minus b into t minus u into du. So, what is the formula we are going to use is direct e power formula. Integration of e power ax is e power ax divided by a. That is only we are going to do. So, here we are going to do some simplifications. Here we have both terms in the power of exponential. So, e power minus bt into e power minus into minus plus and e power bu into du. Here we are going to take a constant outside. So, which one is a constant here? Here we are having variable u. So, with respect to u only we are integrating. So, other variables are constant. So, e power minus bt is constant. So, I am taking that also outside. The integral 0 to t e power minus, I am simplifying these two terms as this, e power minus of a minus b into u into du. Okay. So, here directly we are using the integration formula of e power ax. So, e power minus a minus b into u divided by the constant term is coming for the denominator, that is minus a minus b. Okay. So, here I am applying the lower and upper limit. First upper limit we are going to substitute. So, this minus of a minus b is a constant. So, we are taking that out. Next e power minus of a minus b into t. Next minus e power 0. So, this is the substitution of upper limit, this is a substitution of lower limit. So, here we are going to write it as e power minus at into minus bt, outside there is a 1 e power minus bt. So, that we are going to multiply inside in the both terms. So, after that we are just cancelling this e power minus bt and e power bt. Okay. So, here we are having finally we are having this here one negative, and here also we are multiplying that negative. Finally, we are getting the term like e power minus bt minus e power minus at divided by a minus b, which is the answer for this L inverse of 1 divided by s plus a into s plus b. So, this is the general format. Okay. So, next question also, it is very important question based on the convolution theorem. For when you are entering into your second semester exam, so there will be this problem compulsory. Okay, this is the generalized problem. You can substitute any a here also and any b here. Okay, so as we are doing as already did well, that is a square divided by a square plus a square into a square plus b square, which is can be separated as L inverse of s divided by s square plus a square into L inverse of s divided by s square plus b square. Okay. So, this is the direct formula of L inverse of s divided by s square plus a square, which is when we are having this s term in the numerator, we can use the cos function. Okay. Here we are getting s in numerator, and also here also we are getting s in numerator. So, cos at into cos bt. I am taking f of t as cos at and g of t as cos bt. And by solving the convolution theorem, we want to get that g of t minus u. So, what is g of t minus u? Cos of b t minus u here. Okay. Here formula I am going to use is f of t into g of t, which is equal to convolution of f of t and g of t, which is nothing but the integration of 0 to t f of u into g of t minus u into du. what is your f of u is cos au. Integration 0 to t cos au into what is your g of t minus u is cos b of t minus u into du. Okay, here we are going to integrate. So, which formula can we use for this terms? Here in the term of cos A into cos B. So, what is the formula for cos A into cos B? The formula of cos A into cos B is 1 by 2 into cos of A plus B plus cos of A minus B. Okay, here what is your A? A is considered as AU and B is considered as B of T minus U together. This we can separate as BT minus BU. Just substitute this A and B in this equation. We are getting that 1 by 2 into cos of AU here plus BT minus BU and plus cos of A minus B we have to do here. Cos of A is AU minus BT here, minus into minus is plus BU. Okay. So, we have used this formula for this term. So, here this only we are going to use in the integration form. Okay, here we are going to find e power integration 0 to t, 1 by 2 is a constant and next is cos of, here two terms in terms of u, right. So, I am taking A and B outside and A minus B into u plus B into t. This one term we are having and next cos of A plus B into u, here negative bt is there, so negative bt. Okay, finally we are going to integrate with the variable u. Here what is the integration? We know integration of cos is sine. I am going to use that only. Sine of A minus B into u plus bt. So, which is inside the function sine divided by here coefficient of u is A minus B. Okay. Similarly, we are coming to this term. Here sine of A plus B u minus bt. This is inside the function of sine and divided by using the chain rule we can write A plus B. Okay, here we are having A minus B, here we are having A plus B, that you have to note down. Now we are going to substitute 0 to t our limits. First of all, substitute your upper limit. What is your upper limit? T is your upper limit. A minus B into t plus bt divided by A minus B. Next, substitute upper limit for this term, that is sine of A plus B into t minus bt divided by A plus B. Okay. Now, we are going to substitute upper limit, lower limit. What is your lower limit? Simply 0. You just substitute in here. Sine 0 is 0. And next here sine bt is there, divided by a minus b. Okay, plus sine, here also this term is 0. Here we are having sine minus bt divided by a plus b. So next 1 by 2. Here we can simplify the terms. How we can simplify? Sine of at minus bt here plus bt divided by a minus b. Okay, here also we are going to simplify as a t plus bt minus bt. Okay, divided by a plus b. Next in the upper limit we are having, lower limit substitution, we are having sine bt divided by a minus b. Okay, here plus sine of minus theta is minus sine theta. So that we are using here sine bt divided by a plus b. So just see, here also we are having a minus b, a plus b, a minus b, a plus b. It has some format. Okay, here we just simplify this term. We are getting as sine of here at, here also sine at, here divided by a minus b, here divided by a plus b. When coming to this term, it is also having sine bt minus a minus b, here minus sine bt divided by a plus b. Okay, you just note that these two terms has sine at common and these two terms has sine bt common. You just take that common terms outside. Okay. Okay, I am just taking out 1 by 2 sine at. Here we are having 1 by a minus a minus b, plus 1 divided by a plus b. And in next term minus of, what is the common term? Sine bt is common term. Sine bt into 1 divided by a minus b minus 1 divided by a plus b. Okay, here 1 by 2, just take LCM. When we are taking LCM, what we will get? A plus b plus a minus b divided by a square minus b square minus sine bt into, take LCM, a plus b minus a minus b. Okay, here we can write it as minus a plus b divided by a square plus a square minus b square. Okay, and finally we are getting like 2a into sine at divided by a square minus b square. minus here also 2b into sine bt divided by a square minus b square. Now we are having 2 in numerator and also in denominator. We can cancel it and we can go for the solution of this sum also. Okay, 1 by 2 and 2 will be cancelled. Sine a sine 80 minus b sine bt divided by a square minus b square. So this is the solution for this sum. Okay, so if you another sum is L inverse of some practice problems a square plus 3 square a square plus 4 square. Here some s square is there. How we can solve? Without solving this sum, we can directly say that the answer is, what is your a 3 sine 3t, okay, minus 4 sine 4t divided by 9 minus 60. Okay, so a is 3 here, b is 4 here. So 9 minus 16. 9 minus 16 is, finally you are getting 3 sine minus of 3 sine 3t minus 4 sine 4t divided by 7. Okay, here whether we are getting this answer or not. Can we check that? Same way you have to apply. So L inverse of a square divided by b square into a square plus 4 square, which can be written as L inverse of s divided by a square plus 3 square into L inverse of s divided by a square plus 4 square. We can use the direct formula. Okay, it is cos 3t into cos 4t. Here f of t is cos 3t and g of t is cos 4t. So to find a convolution theorem, we have to know what is f of u and what is g of t minus u. So f of u is cos 3u and g of t minus u is cos 4 into t minus u. Okay, here also we are using the convolution in the format of integration of 0 to t. F of u is cos 3u into cos of 4t minus 4u. Okay, here into du will be there. Here cos A, and here it is in the format of cos B. Cos A, cos B formula is 1 by 2 into cos A plus B plus cos of A minus B. So, here 1 by 2 into cos of A is 3u plus 4t minus 4u plus cos A minus B is cos of 3u minus 4t here plus 4u. Okay, what we are having? Cos of here minus 4t minus u we are having. Here we are having that cos of 7u minus 4t. Okay, so this only we got finally. We are going to substitute this in the integration. So what is your integration? We will see that. Okay, now we are going to integrate 0 to t cos 1 by 2 is a constant, 1 by 2 cos of 4t minus u plus cos of 7u minus 4t into du. So similarly, we can use the sine formula here. How will you use sine of 4t minus u divided by, here your constant is minus 1. Okay. Next, plus cos of, sorry, integration is sine is right. Sine of 7u minus 4t, which is will be divided by 7. 0 to t. Apply your limits. What is your limit? 0 to t. Here we are having, first you will apply your limit. Here sine of 4t minus t divided by minus 1. Here sine of 7u minus, so 7t minus 4t divided by 7 minus your limits. So here 0 sine of 4t minus 1 minus plus sine of here 7t minus 4t. Here when you are substituting 0 sine of minus 4t divided by 7. Okay. Here what you will get? 1 by 2 into sine 3t minus 1 plus sine 3t by 7 minus sine 4t divided by minus 1. Here minus sine 4t divided by 7. Here sine 3t it is in the both terms. Here sine 4t, it is in the both terms. So we are going to take both the things common. Sine 3t minus 1 plus 1 by 7. Here sine 4t minus 1 minus 1 by 7. Okay, just take LCM. 1 by 2 sine 3t, here minus 7 plus 1 divided by 7 minus sine 4t, LCM is minus 7 minus 1 divided by 7. Okay, so finally we can write it as 1 by 2 sine 3t, here we are having minus 6 by 7, here we are having sine 4t here okay, okay, here finally we are having the value of minus 8 divided by 7. Okay, 1 by 2, here we can separate the terms. How we can take 2 here, so 2 into sine 3t minus 3, here also we can take 2 outside, so sine 4t minus 2, okay, sorry, minus 4 divided by, here also there is a 7, here also there is a 7. So just cancelling out the terms, minus of 3 sine 3t minus, here we are having minus of minus is 4, 4 sine 4t divided by 7. So this is A sine 8t my B sine bt divided by, it is in the form of a square minus b square. So we got this negative we have taken out. Okay, so this is the procedure to find the inverse Laplace transformation. So there are so many rules also. First shifting rule, second shifting rule. So that and all we are not using in this convolution theorem. So I am not teaching that now. So if you want to go through, you can go for your, you can take your engineering mathematics books. You can see that. Okay. So till now we have studied some important formulas of inverse Laplace transforms and what is a convolution. So basically convolution is a, if you have two functions you can define it as only integration, right? So in conclusion we have studied the convolution. What is convolution? If you have two function f of t and g of t, we will have the format of f of t and g of t. with this star will denotes your convolution, which is equal to nothing but 0 to t f of u into g of t minus u into du. Okay, so by using this convolution, we are going for the convolution theorem. What is a convolution theorem? The Laplace of the convolution of two functions. Okay, so Laplace of, that means Laplace means L of convolution of two functions f of t and g of t, which is equal to the product of Laplace of f of t into L of g of t. Okay, so here we have done with what is your convolution, what is your convolution theorem and all. Okay, I will give more problems to your practice also. You can take that problems also. So we have done what is convolution, what is convolution theorem. From this only, this is for Laplace transformation. We have converted that to the inverse Laplace transformation and we have done the problems. Okay, so more than 5 problems we have done. Some practice problem also you can note. Laplace inverse of 1 divided by s plus 3, s plus 5. This general format I have taught today. The second sum is Laplace inverse of s square divided by s square plus 5 square, s square plus 6 square. Okay, and here third we have studied about some s divided by s plus 2, s square plus some 4 square. This also you can try. Okay, so what is the application of inverse Laplace transformation? Inverse Laplace transformation. So we are finding the inverse Laplace transformation and where we are using that exactly. So main application of Laplace transform as well as inverse Laplace transformation is to finding the solution for the second order differential equation. Okay, so in that also we are using that Laplace transformation, that is very main. If we have some differential equation and also with some initial and boundary conditions, we can use that by the Laplace inverse transformation also. There is also some formulas of that. Directly we can use that formulas and we can reduce our differential equation in the Laplace transformation, and finally we are going to find that Laplace formulas and we are applying Laplace formulas. Finally we are getting the solution to the Laplace differential equations. Okay, thank you.